students. So last class we discussed the oxides of nitrogen, right? So what is the structure of oxides of nitrogen? What is the resonating structures? So last class we studied in details. So see, the last class ಬರ್ದಿದೆ ನಿಮಗೆ structures ಯಾವ ತರ contribute ಮಾಡುತ್ತೆ, how to convert the different resonating structures of the oxides of nitrogen. See, this is actually diagram showing the resonating structures of the different oxide form of nitrogen. So ನಾನು ಹೇಳಿದೆ ನಿಮಗೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೀಗೆ ಬರೀಬೇಕಂತ ಏನಿಲ್ಲ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೈಕ್ ಅದು ಯಾವ ತರ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ರೆಸೋನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ ರಿಕಾರ್ಡ್ ಆಸ್ ಅ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗ್ಬೋದು. ಅಗೇನ್ ಇನ್ ಬಿಟ್ವೀನ್ ದ ನೈಟ್ರೋಜನ್ ಅಂಡ್ ಆಕ್ಸಿಜನ್ ಮಧ್ಯೆ ಇರುವಂತ 5 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗ್ಬೋದು. ಅದು ಯಾವ ತರ ಎಲೆಕ್ಟ್ರಾನ್ ಲೈಕ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ ಸೊ ಬರೀಬಹುದು. ಸೊ ಸಿ ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಲೈಕ್ ದ ಫ್ಲೋ ಚಾರ್ಟ್ ಅಥವಾ ಇಟ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಡಯಾಗ್ರಾಮ್ ದ ಶೋಯಿಂಗ್ ದ ರೆಸೋನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್. They showing resonating structure. Based on this resonating structure, we have to conclude what is the bond parameters. For example, bond length agbodu, again bond in between the nitrogen ಮತ್ತೆ nitrogen agbodu ಅಥವಾ nitrogen oxygen ಮಧ್ಯೆ ಏನಾಗುತ್ತೆ the bond angle and bond length we call as bond parameters ಅಂತ ಕರೀತೀವಿ. So ಯಾವ ತರ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ in the form of the different oxides. We'll see the first one is dinitrogen oxide is one of the oxide of nitrogen. In this case, see, we have to see the resonating structure. Again, there is a 2 nitrogen atom, again 1 oxygen atom. It is undergo the resonance we call as a resonating contribution structures anta karithivi. So last class ಅಲ್ಲಿ ಯಾವ ತರ ಮೂವ್ಮೆಂಟ್ ಆಗುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂತ ತೋರಿಸಿದ್ವಿ ಹೌದಲ್ವಾ. So in this case 2 electrons, already 2 electrons ಇದೆ. One of the pair of electrons shifted towards nitrogen. The next nitrogen ಕಡೆ ಏನಾಗುತ್ತೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. Again, in between nitrogen and oxygen madhe ಇದೆ bond ಇದೆ ಅಲ್ವಾ, the bond pair of electrons shifted towards oxygen. This is we called as a resonating structure. So this is a resonating structure. In case of the bond parameters, this is a linear structure anta ಕರೀತೀವಿ. ನೋಡಿ ಇಲ್ಲಿ in between see 2 nitrogen atoms ಇದೆ, 1 oxygen atom ಇದೆ. Within as a bond parameter we called as a bond length and the bond angle. So based on this structure, we called as the shape of the molecule or weakness oxide of nitrogen exhibit linear structure. Linear structure. See, weakness of the bond length in between nitrogen ಮತ್ತೆ nitrogen ಮಧ್ಯೆ ಏನಾಗುತ್ತೆ 130 picometer ಇರುತ್ತೆ. In case of nitrogen oxygen 190 picometer ಇರುತ್ತೆ. This is a variation of the bond length in a different atoms. For example, nitrogen bond, again nitrogen oxygen bond. In case of the oxides of nitrogen, we called as a dinitrogen oxide. The second one is we called as this is called as a nitric oxide. It is also one of the oxide of nitrogen. We have studied in details how to contribute the resonating structure. It is also having one of the odd electron, odd number of electron in case of nitrogen. Again, it is shifted towards oxygen. We called as the contribution of resonance. We called as a resonance. So because of presence of one of the odd electron in case of oxygen, it ಏನಾಗುತ್ತೆ nitrogen ಕಡೆಗೆ ಏನಾಗುತ್ತೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ either towards. For example, see this symbol indicates, for example ಈ ಕಡೆಯಿಂದ for example ಅಲ್ಲಿ ಮಾಲಿಕ್ಯೂಲ್ ಅಂತ ಉಲ್ಟಾ ಇದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಕೆಲವೊಮ್ಮೆ ನಾವು ಬರೀಬೇಕಾದ್ರೆ ಇದನ್ನ ತಗೊಂಡಿರ್ತೀವಿ. ಸೊ it is a resonance based on resonance. ಯಾವುದೇ ಮಾಲಿಕ್ಯೂಲ್ ನ ಬೇಕಾದ್ರೂ ತಗೋಬಹುದು. ಅದಕ್ಕೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ ಇದೇ ಬಾಂಡ್ ನ ತಗೋಬೇಕಂತ ಏನಿಲ್ಲ, ಬಟ್ we have to see the bond base and lone base. Based on bond base and lone base, we have tried different resonating structure, resonance contribution structures ಅಂತ ಕರೀತೀವಿ. Okay na? So in this case we have to see nitrogen ಮತ್ತೆ oxygen bond ಇದೆ ಹೌದಲ್ವಾ. So only in case of nitric oxide, see the bond length is equals to 115 picometer. So we have to observe the same nitrogen oxygen bond ಏನಾಗುತ್ತೆ in case of the oxide of see dinitrogen oxide ಅಲ್ಲಿ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ 190 picometer ಬರ್ತಾ ಇದೆ. But in case of the oxide of see the second one we called as a nitric oxide ಅಂತ ಕರೀತೀವಿ. ಅದರ ಸೇಮ್ atoms ಮಧ್ಯೆ the bond length ಏನಾಗ್ತಾ ಇದೆ ವೇರಿ ಆಗ್ತಾ ಇದೆ. So the variation of bond length is also shows the shape of the molecule, the different shape of the molecule. It may depends on the number of electron. It may be depends on the bond base and the lone base. Okay. So next we come back to the third one. It is one of the oxide of the nitrogen. So in this case we called as the dinitrogen trioxide anta karitivi. So last class we discussed the resonating structure. So based on this resonating structure we have to see the bond parameter we called as see the bond length and especially the bond angle. In between nitrogen and oxygen having the bond angle is 105 degree. Okay, 105 degree. Again come back to this bond length we called as see nitrogen oxygen madhye enagutte bond length is equals to 114 picometer. See we have to see the difference. In case of the first common oxide is a 190, again 150, again come back to the same nitrogen and oxygen again after that 114 picometer. Okay, it may depends on the lone phase and bond phase, the same in the compounds. Okay, next the same nitrogen ಏನಿದೆ, we have to see the bond length. It is equal to 186 picometer, but we have to see in case of the first one of the oxide we call as a dinitrogen oxide is equal to 113 picometer. Same ಇರೋದಿಲ್ಲ, ಬಾಂಡ್ ಸೇಮ್ ಇರಬಹುದು, ಆಟಮ್ ಸೇಮ್ ಇರಬಹುದು, ಬಟ್ ಅಟಮ್ ಮತ್ತೆ ಬಾಂಡ್ ಲೆಂತ್ ಆಗೋದು, ಬಾಂಡ್ ಆಂಗಲ್ ಏನಾಗುತ್ತೆ ವೇರಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. It depends on bond phase and lone phase. So only depends on bond phase we have to write the structure, we have to predict the structure of a molecule. Okay, same atoms ಇದ್ರೆ ಏನಾಗುತ್ತೆ, ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಇದೆ ಅಲ್ವಾ, the bond phase ಮತ್ತೆ lone phase. So based on this the structure also changes, the structure also changes. So ಇಲ್ಲೇ ನೋಡಬಹುದು ನೋಡಿ, ಹೌದಲ್ವಾ, ಸೇಮ್ ಅದೇ ಮಾಲಿಕ್ಯೂಲ್ ಮತ್ತೆ ನೋಡಿ ನೈಟ್ರೋಜನ್ ಮತ್ತೆ ಆಕ್ಸಿಜನ್ ಬಾಂಡ್ ಇದೆ, again ನೈಟ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ ಬಾಂಡ್ ಇದೆ. In between is oxygen, nitrogen, oxygen. Oxygen, nitrogen, oxygen. We take as a bond angle is equal to 130 degree. Is equal to 130 degree. Again, come back to this. See, this nitrogen, again nitrogen, oxygen. This is also another bond angle. We call it as the three, in between three atoms. Nitrogen, nitrogen and oxygen. See, it is equal to the 186 picometer. Bond length in between nitrogen and nitrogen. But in case of bond angle nitrogen, nitrogen, oxygen, the bond angle is 117 degree. See, inga vary ಆಗ್ತಾ ಇದೆ. Okay na? Next come back to this. See, based on this structure, nothing but bond phase, lone phase, and contribution of the bond length and bond angle, we have to conclude the shape of the molecule or the structure of the molecule. We call it as a dinitrogen trioxide. The shape is planar. The shape is planar. The next one is, see, the next oxide we call as a nitrogen dioxide and the nitrogen dioxide. This is the structure of nitrogen dioxide. Again, it is also undergo resonance. We call it as a resonating structure. So based on this resonance, we have to predict the bond parameters. The bond parameters. See, this is a nitrogen. So in nitrogen, it is connected to two oxygen atoms. So in this case, each nitrogen and oxygen, we call it as a bond length. In between two atoms, we call it as nitrogen and oxygen. Their bond length is 120 picometer in each cases. In each cases of nitrogen oxygen bond. Again, come back to the based on this the structure, the bond angle between oxygen, nitrogen and oxygen is equal to 134 degree. 134 degree. This is the bond angle between three atoms. We call it as oxygen, nitrogen and oxygen. Okay, next is based on these structures, nothing but based on the presence of lone phase and bond phase and the resulting structure, it exhibits or is occupies the structure we call as angular structure, the shape of the molecule. So based on the bond phase and lone phase is angular structure. Yavudu molecule ಇಲ್ಲಿ nitrogen dioxide. Okay, so next the oxide of nitrogen is a dinitrogen tetroxide. It is called as a resonating structure. So last class we studied details. Outer formation of the resonating structure. So how to like convert? So based on putting as a pair of electrons ಅಥವಾ ಈ pi electrons ತಗೋಬಹುದು ಅಥವಾ putting as a lone pair of electrons ತಗೋಬಹುದು. ಯಾವ ತರ ಅದಕ್ಕೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ? So based on the distributed, how to exhibit this structure? We call it as a resonating structures. So ಅದು ಯಾವ ತರ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ ಸ್ಟ್ರಕ್ಚರ್ ನ? So last class ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ ಹೌದಲ್ವಾ? It is called as a resonating structure. So based on these resonating structures, bond phase and lone phase, so we have to predict the bond parameters in between atoms in the molecule. So example, nitrogen, oxygen ಮತ್ತೆ oxygen. ಹೌದಲ್ವಾ? See, in between oxygen, nitrogen and oxygen, the bond angle is 135 degree. See, in this case, same again for oxygen ಮತ್ತೆ nitrogen, oxygen. But in case previous oxide we call it as C, this is a nitrogen dioxide ಅಂತ ಕರೀತೀವಿ. ಇದು ಕೂಡ ಏನಾಗುತ್ತೆ, 3 atoms ಮತ್ತೆ ಸೇಮ್ atoms ಮತ್ತೆ bond angle ಬರುತ್ತೆ. It is equals to 134. Here also 135. Just variations. ಯಾಕೆ ಈ ತರ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ? Again come back to the bond phase and lone phase. Okay, you have studied in details chemical bonding and study ಮಾಡಿರ್ತಾರೆ detail ಆಗಿ ಹೌದಲ್ವಾ? Always we have to predict the structure or shape of the molecules based on bond phase and lone phase other than hybridization. Okay, so this is we called as based on this resonating structure. It is also exhibit the planar planar molecule. Okay, this is called as a planar structure. So in this case, see, we have to see nitrogen again, oxygen is there, again you put oxygen body. Same as the next we called as oxide of nitrogen. Instead of nitrogen in extra oxygen molecule in another formation. This is we called as a dinitrogen pentoxide. It is also one of the oxide of nitrogen. See, in this case also we have to see the variations. In between bond length, the nitrogen and oxygen is equals to 151 picometer. But in all the cases, the nitrogen oxygen bond bond length vary ಆಗ್ತಾ ಹೋಗ್ತಾರೆ. So actually, ನಿಮ್ಮ theory ಏನು questions ಕೇಳೋದಿಲ್ಲ, but ಕೇಳಿದ್ರೆ ಅವರು ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಈ ಬಾಂಡ್ ಪ್ಯಾರಾಮೀಟರ್ ರಿಕಾರ್ಡ್ ಆಸ್ ಅ ಬಾಂಡ್ ಲೆಂತ್ ಮತ್ತೆ ಬಾಂಡ್ ಆಂಗಲ್ ವೇರಿ ಆಗ್ತಾ ಇದೆ, ಬಟ್ ಸೇಮ್ ಆಟಮ್ಸ್ ಇದೆ ವೇರಿ ಆಗ್ತಾ ಹೋಗ್ತಾರೆ. So what is the reason here? The reason is presence of the bond pairs and lone pair of electron. Again, based on bond pairs and lone pair, they involve we call as a structure, contributing structures or resonance structures ಅಂತ ಕರೀತಾರೆ. It may depends, how will may depend on the structure. Okay, now it's very important for our competitive exam. So based on the bond pairs, lone pairs, bond angle, we have to predict the bond angle and the bond length in between the atoms. Okay, so this also occupy the last oxide of nitrogen as a planar structure. Same ಇದೆ ನೋಡಿ, nitrogen ಇದು oxygen ಇದೆ, ಏನಿದೆ nitrogen. ಈ ಫೋಟೋ ಅಂತ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಒಂದು ಆಕ್ಸಿಜನ್ ಮಾತ್ರ ಏನಾಗುತ್ತೆ ಅಡಿಷನ್ ಆಗುತ್ತೆ. ಹೇಗೆ ಬರೀಬೇಕು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಂತ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ. Okay, now this is we called as bond parameters. Bond parameters, the bond length ಆಗ್ಬೋದು ಮತ್ತೆ bond angle. So based on this, is of the structure also varies. So different oxides of nitrogen occupies the different structures. Okay, it depends on bond pairs and lone pair of electron, not only hybridization. Okay, now so this is regarding the oxides of nitrogen. So yesterday class we studied in details. Okay, so this is regarding for your competitive exams. ಯಾವ ತರ ವೇರಿ ಆಗುತ್ತೆ, ಸೇಮ್ ಆಟಮ್ಸ್ ಇರುತ್ತೆ, ಸೇಮ್ ಬಾಂಡ್ ಇರುತ್ತೆ, ಬಟ್ ಡಿಫರೆಂಟ್ ಆಕ್ಸೈಡ್ಸ್. ಸೊ ಡಿಫರೆಂಟ್ ಆಕ್ಸೈಡ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆದಾಗ ಯಾವ ತರ ವೇರಿ ಆಗುತ್ತೆ, ಸೊ ಯಾಕೆ ವೇರಿ ಆಗುತ್ತೆ, they will ask questions. Okay, so this is regarding the oxides of nitrogen. Okay, today so let us discuss the other element belong to the same family. So last class I told you one of the element belongs to the same family we called as a phosphorus, right? So in this case, the same group we called as a 15, the group 15. So usually this group 15 elements we called as a nitrogen family elements and or it is also called as nicogens, right? So what is mean by nicogens? Usually in nitrogen they exhibit the different properties in the group 15. So ಯಾವುದೇ ಒಂದು ಗ್ರೂಪ್ ಅಲ್ಲಿ particular one of the element they exhibit different properties. So ಅದನ್ನ ಬೇಸಿಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ನಾವು ಏನು ಮಾಡ್ತೀವಿ, we have to show or we have to call the group elements. So usually the first element in the family we called as a nitrogen. ಅದಕ್ಕೆ ನಾವು nitrogen family ಅಂತ ಕರೀತೀವಿ. So almost ಏನಾಗುತ್ತೆ, ಈ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾಗುತ್ತೆ ಸೇಮ್ ಪ್ರಾಪರ್ಟೀಸ್ ನ ತೋರಿಸುತ್ತೆ. So ಸೇಮ್ ಪ್ರಾಪರ್ಟೀಸ್ ತೋರಿಸೋದ್ರಿಂದ ನಾವುಗಳು ಏನು ಮಾಡಿದ್ರೆ ಒಂದೇ ಗ್ರೂಪ್ ಅಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಅರೇಂಜ್ ಮಾಡ್ತೀವಿ. So we have to see, we have to study the arrangement of periodic table. So first class alle study ಮಾಡಿದ್ವಿ, first year ಅಲ್ಲಿ ಅದರಲ್ಲಿ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂತ ಹೇಳಿರ್ತೀವಿ, ಹೌದಲ್ವಾ? ಸೊ ಯಾಕೆ ಎಲಿಮೆಂಟ್ಸ್ ನ ಒಂದೇ ಗ್ರೂಪ್ ಅಲ್ಲಿ ನಾವು ಅರೇಂಜ್ ಮಾಡಿರ್ತೀವಿ, ಹೌದಲ್ವಾ? ಸೊ ವೈ? ಬಿಕಾಸ್ the properties. So same in case the phosphorus also having some of the properties like similar to the nitrogen. For example, chemical properties agbodu, it also forms some of the compounds like nitrogen oxides agbodu, ಅಥವಾ different compounds ಏನಾಗುತ್ತೆ formation ಆಗುತ್ತೆ. It is also exhibit some of the chemical properties. It is also shows physical properties. It is also exhibit the different structures we call as allotropes. Okay, so we have to study it in details today. The next element belong to the family we call as a group 15 is the phosphorus. The phosphorus having the symbol is a P. P is indicates the symbol of phosphorus. The atomic number of phosphorus is atomic number is 15. Okay, this phosphorus also having different oxidation state we call as a multivalent ಅಂತ ಕರೀತೀವಿ. So ನಾವು already study ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ anomalous properties of nitrogen ನ ಹೇಳಬೇಕಾದ್ರೆ we have to compare the remaining element to nitrogen. ಈ ನೈಟ್ರೋಜನ್ ನ ಬೇಸಿಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ಏನು ಮಾಡ್ತೀವಿ, ರಿಮೈನಿಂಗ್ ಎಲಿಮೆಂಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಗೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಕಂಪೇರ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ ನಾನು, the nitrogen exhibit the maximum covalency is a +4, right? It is also exhibit the different oxidation state we called as a +1, +2, +3. Right. So in that case, the remaining elements we call as a phosphorus and other elements belong to the same family. It is also exhibit the different oxidation state. Compared to the element, the same element we call as a phosphorus, the phosphorus exhibit the different valence state in the different compounds. So only the phosphorus exhibit a multivalence in different compounds. So only it is called as the multivalent nonmetal. It is a multivalent nonmetal. The phosphorus, the symbol of phosphorus is a P. So we have to indicate the phosphorus in periodic table. The symbol is P. Atomic number is 15. It is also multivalent nonmetal. It is an example for a nonmetal. Again, it is a multivalent. So multivalent it is produced or it is the forms different state. We call it as a valence state and the collective, the valence oxidation state and the collective. So in a different compound. So only we call it as a multivalent nonmetal. Multivalent nonmetal. Okay. So next, come back to this phosphorus. This phosphorus exhibit different forms, or it is also shows the different form of a structure. Same element, but is showing different form of a structure. The element shows different form of a structure. The property we called as allotropes. Okay, it is also exhibit allotropic nature. Allotropic in nature. Nothing but it is also exhibit allotropes. This phosphorus exhibit the many structures, many different structures. Usually we call it as the allotropic structure. In that some of are stable. So tumma different structures formation agate. In case of phosphorus we call it as allotropes. In that allotropes quite stable structures we have seen. So other stable structures and the stable formation aguvantu we call it as a different allotropes and the connectivity. So the first example is a white phosphorus. Allotropic in nature. The allotropes of phosphorus is white phosphorus, the second one is red phosphorus, next one is black phosphorus. See, these are the stable different allotropes of phosphorus. Okay, the first one is a white phosphorus, the second one is a red phosphorus, the third one is a black phosphorus. So we call it as the different structures and the activities also exhibit the different form of a structure, but same element we call it as a phosphorus. So we have to study in details. So what is a white phosphorus? How can exist? How form will exist? So what is like reactivity? What is the physical nature, chemical nature? We have to study in details. Next, red phosphorus, same thing here. So what is the physical nature? How can they exist in the form of a different structure? How the structure will exist? Okay, now we have to study in details. Even black phosphorus also. The first one is white phosphorus. The white phosphorus is one of the allotrope of phosphorus. It is basically solid. We call it as a white waxy solid at the correct. So note like a phosphorus usually it is we called as a translucent at the correct. We call it as a translucent. So usually the translucent white waxy structure. It is also called as white waxy solids at the correct. Okay. The first one is white phosphorus. The white phosphorus is translucent white waxy solid. Actually it is a soft in nature. Okay, now soft agirutte. Again it is a solid and waxy in nature. So wax tara it's like gummy. Okay. So basically we call it as a translucent white color waxy solid and the correct. Again, this white phosphorus exists in a form, we call it as a molecular form and the correct. This white phosphorus exists in the form of molecular state exist P4 in the form of P4. So it is a P4 structure. We call it as a molecular form of white phosphorus. Is a P4. In this case, we call it as the 4 phosphorus atoms in the way. The 4 phosphorus atoms are linked together to form one of the molecule. We call it as one of the structure, that is white phosphorus. If 4 molecules, for example, 4 atoms of phosphorus, how they are arranged in the fashion. Each atom of phosphorus, it occupies regular tetrahedral structure. So we have to see the tetrahedral structure like this fashion. For example, 4 atoms of phosphorus is there. This is one of the phosphorus atom. Okay. So again, another phosphorus atom. So this is we call it as regular tetrahedral structure. In regular tetrahedral structure, each corners is occupied each atom of phosphorus. Each atom of phosphorus, it is occupied the corners of tetrahedral. This is we call it as a regular tetrahedral structure. Regular tetrahedral. In regular tetrahedral structure, each carbon is occupied 1 atom of phosphorus. So, 4 atoms of phosphorus are arranged regular tetrahedral structure. It forms one of the molecule we call as P4. It is a white phosphorus. It is a white phosphorus. In between these P and P, bond angle is equals to the 60 degree. We call as a bond angle in between each phosphorus bonds. Okay, na? The bond angle we call as the angle strain is equal to the 60 degree. In case of this white phosphorus, okay, the white phosphorus, it is insoluble in water. It is insoluble in water. Insoluble in water, but it is soluble in carbon disulfides. It is soluble in carbon disulfide. It is one of the solvent. It is a good solvent in which this white phosphorus is soluble. Okay, this is regarding some of the physical properties of this white sulfur. Sorry, white phosphorus, not a sulfur. It is a white phosphorus. Actually, so based on this structure, see now we know the angle strain and the curve. Udhar one we complex example one question get. So actually this phosphorus exists in the form of a P4 structure. P4 structure. So 4 atoms of phosphorus is there. So molecular state in P4 form exists. So based on this, actually the white sulfur are very reactive. Nothing but is a less stable. It's a very important. This white phosphorus is less stable. It is less stable. So because of the stability, we call it as less stable. It's more reactive. It's more reactive. So more reactive because it is less stable. Less stable because of the angle strain between phosphorus atoms. The angle strain between phosphorus atoms is 60. Is a very less. Less area, just area, just only 60. Okay, na? So what is the reason? The reason is this phosphorus is less stable because it's more reactive due to the angle strain between phosphorus atoms. Between phosphorus atoms is equals to 60 degree. So because of this reason, it is less stable and more reactive. Okay. So again, this white phosphorus is more reactive. So it is readily reacts with oxygen. So because of this reactivity, this white phosphorus is readily reacts with oxygen. It actually reactor it gives rise to the white fumes. White fumes substance formation actually ಈ reactivity ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ white phosphorus ಏನಾಗುತ್ತೆ ಓಪನ್ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಹಾಗೆ ಇಟ್ಟಾಗ ಏನಾಗುತ್ತೆ so it is catches fire but it is reacts with oxygen so only it is called as a poisonous. This white phosphorus is a very poisonous, it's a toxic in nature. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದೇರ್ ರಿಯಾಕ್ಟಿವಿಟಿ. ಸುಮ್ಮನೆ ಇರಲ್ಲ ಅದು, ಓಪನ್ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಹಾಗೆ ಇಟ್ಟರೆ ಅಥವಾ ಓಪನ್ ಆಗಿ ಹಾಗೆ ಇತ್ತು ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಈಸಿಯಾಗಿ ಏನಾಗುತ್ತೆ, ರೆಡಿಲಿ ಇಟ್ ಈಸ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ಆಕ್ಸಿಜನ್ ಟು ಕ್ಯಾಚಸ್ ಫೈರ್. ಟು ಕ್ಯಾಚಸ್ fire, it gives this to one of the component we call as the white color fumes ಅಂತ ಕರೀತೀವಿ. The white color solid substance ಏನಾಗುತ್ತೆ, formation ಆಗುತ್ತೆ. We'll see the reaction. It is reacts with the oxygen. White phosphorus, they present in the form of P4. It's a molecular formula. The existing molecular formula for white phosphorus is a P4 state. It is reacts with oxygen. We call it as oxygen here. 5 molecules of oxygen jothe enagutte react agutte. Nothing but it's a readily reactive. It's a readily reactive with oxygen to give such white color fumes. For example, see this is we call as a P2O10. See here. For use of molecules ಏನಾಗುತ್ತೆ, ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. In this case we call as P2O10 ಏನಾಗುತ್ತೆ, ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಓಕೆನಾ. ಸೊ ಯೂಶುವಲಿ we have to write the molecular state, the different compounds ಏನಾಗುತ್ತೆ, ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. It readily catches fire. A white color fumes ಏನಪ್ಪ ಇಲ್ಲಿ ಅಂತಂದ್ರೆ, this is a white color fumes. ಈ ಆಕ್ಸಿಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, white color fumes ಏನಾಗುತ್ತೆ, ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. So usually in this case we have to say 5 2s are 10 ಬರುತ್ತೆ, P2O5 it makes a 2 molecules of formation ಆಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So in this case you have to see the P2O10 formation ಆಗುತ್ತೆ, P4O10 formula ಏನಾಗುತ್ತೆ, formation ಆಗುತ್ತೆ. So this is we called as a reactivity. So what is reactivity here? This phosphorus is a readily catches fire when it is reacts with the oxygen. When it is reacts with oxygen, so only we have to write the 4 atoms of phosphorus. It reacts with the 5 molecules of oxygen. It gives us to P2 and P4O10 molecule of this phosphorus. We call as, usually this is called as the phosphorus antane karithivi, the phosphorus oxides anta karithivi. Phosphorus oxide is a very important. Okay na, ee air alli oxygen jothe react agadi yav ತರ chemical reactions formation agutte. Okay, the next we have to see the red phosphorus. The next form of phosphorus we call as allotropic form of phosphorus anta karithivi. The next form is so usually see this is a phosphorus reactivity. ನೋಡಿ ಇಲ್ಲಿ ಒಂದು CET ಕ್ವೆಶ್ಚನ್ ಕೇಳಬಹುದು, ಈ ವೈಟ್ ಕಲರ್ ಫ್ಯೂಮ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿ, ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಪಾಯ್ಸನಸ್ ಆಕ್ಚುಲಿ, ಹೌದಲ್ವಾ? ಸೊ ಬೇಸಿಕಲಿ ಇದು ಕಾಂಪೌಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಓಕೆನಾ, ಬಟ್ 100% ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ದ ಕೇಸಸ್ ಈ ಕಾಂಪೌಂಡ್ ಮೇಜರ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ, P4O10. ಓಕೆನಾ. ಸೊ ದಿಸ್ ಇಸ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ ವೈಟ್ dense white fumes ಅಂತ ಕರೀತೀವಿ. dense white fume substance. Okay, so ಹಾಗಾಗಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೇಸಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಕಾಂಪೌಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಇದು ರೇರ್ ಕೇಸಸ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ. ಓಕೆನಾ, ಇಸ್ ಹೈಲಿ ಪಾಯ್ಸನಸ್. ಇದು ಕೂಡ ಏನಾಗುತ್ತೆ, ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ನಿಮಗೆ. ಓಕೆನಾ, ಇಸ್ ಹೈಲಿ ಲೈಕ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್. ಈಗ ಕಂಪ್ಲೀಟ್ ಒಂದೇ ಸಲ ರಿಯಾಕ್ಷನ್ ಎಟ್ ಟೈಮ್ ಆಗುತ್ತಾ, ಇಲ್ಲ. It gives rise to the different intermediate compounds, but finally we get this is a white color fumes. Okay, so this is one of the chemical reactivity of the chemical property of again phosphorus also. We call it as a white phosphorus when it is readily react with the oxygen. The next form of phosphorus we call as allotrope is a red phosphorus. So it is a red phosphorus. It is the next allotropic form of a phosphorus. It is not so much poison like white phosphorus. Okay, it is also exhibit a solid form. We call it as a crystalline solids anta karithivi. So compared to the red phosphorus, it is odd in nature. So quite odd in nature. So usually red phosphorus enagutte hard agirutte, but white phosphorus ತುಂಬಾನೇ ಸಾಫ್ಟ್ ಆಗಿರುತ್ತೆ. It is a poison in nature. ತುಂಬಾನೇ poison ಯಾವುದು white phosphorus, but compared to white phosphorus the red poison is not a poison. So ಅಷ್ಟೇನು ಇದು poison ಅಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ತುಂಬಾ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So we have to prepare the red phosphorus by using a white phosphorus only. ಈ white phosphorus ನ ಏನ್ ಮಾಡ್ತೀವಿ, ಸರ್ಟೈನ್ ರಿಯಾಕ್ಷನ್ ಕಂಡೀಷನ್ ಅನ್ನು ಮೇಂಟೈನ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ನಮಗೆ ರೆಡ್ ಫಾಸ್ಫರಸ್ ಏನಾಗುತ್ತೆ, ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ಯಾವ ತರ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ, ಯೂಶುವಲಿ we declare white phosphorus. The white phosphorus while heating the temperature range is equal to the 573 Kelvin. We declare white phosphorus heated in presence of see called as the temperature range 573 degree Kelvin, 573 degree Kelvin in presence of it is a temperature in which case we have to maintain the certain reaction condition. Nothing but the reaction ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಆ ಸುತ್ತ ಏನು ಮಾಡಬೇಕು, ಆ ರಿಯಾಕ್ಷನ್ ಇರುತ್ತಲ್ವಾ, we have to inert ಆ ಸುತ್ತ ರಿಯಾಕ್ಷನ್ ಕಂಡೀಷನ್ ಏನಿರುತ್ತೆ, ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾದ ಪ್ಲೇಸ್ ಏನಿರುತ್ತೆ, whatever it is. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು ರಿಯಾಕ್ಷನ್ ಕಂಟೈನರ್ ನ ತಗೊಂಡಿದೀವೋ ಅಥವಾ ರಿಯಾಕ್ಷನ್ ಮಿಕ್ಸ್ಚರ್ ನ ತಗೊಂಡಿದೀವೋ ಗೊತ್ತಿಲ್ಲ, ಸುತ್ತ ಇರುವಂತ ಅಟ್ಮಾಸ್ಫಿಯರ್ ನಾವು ಏನ್ ಮಾಡಬೇಕು, ಇನರ್ಟ್ ಮಾಡಬೇಕು. ಎಸ್ಪೆಷಲಿ ಇನರ್ಟ್ ಮಾಡಬೇಕಾಗಿರೋದು ಯಾವುದ್ರ ಜೊತೆ ರಿಯಾಕ್ಷನ್ ಆಗೋದನ್ನ ತಡಿಲಿಕ್ಕೆ ಅಂದ್ರೆ ನೈಟ್ರೋಜನ್ ಜೊತೆ. is a very reactive towards nitrogen, so only we have to do inert condition, we have to like provide the inert condition surround the thickness white phosphorus when it is heated in presence of temperature 573 Kelvin, 573 Kelvin. So usually the white phosphorus heated in presence of 573 Kelvin inert atmosphere of nitrogen, inert atmosphere of nitrogen, it gives rise to red phosphorus. Okay, this is one of the method for the preparation of red phosphorus from white phosphorus. Okay, come back to some more properties this white phosphorus and the red phosphorus. So last class I told you this white phosphorus is a readily react with concentrated NaOH. ಹೌದಲ್ವಾ, ಈ concentrated NaOH ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, one of the gas we call as a famous compound formation ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದೆ. You will ask your competitive exam the past things. The phosphine gas is obtained or formed when this white phosphorus reacts with the concentrated NaOH called as a sodium hydroxide. White phosphorus, we have to see the symbol P4, when it is reacts with the 3 molecules of NaOH. 3 molecules of NaOH plus 3 molecules of water here, it gives rise to phosphine. What is the formula for phosphine? PH3. This is called as a phosphine. With the elimination of the byproduct we call as, see this is a sodium hydrogen, see water molecules idya, we call as this is a phosphate formation agide. Yadra sodium hydrogen phosphate is also called as sodium hypophosphite. Sodium hypophosphite, NaH2PO2. NaH2PO2 we call as sodium hypophosphite is a byproduct. Okay, so when phosphorus reacts with concentrated NaOH, which type of phosphorus? The white phosphorus is react with concentrated NaOH, it gives rise to one of the famous compound we call as a phosphine. It is also one of the method for the preparation of phosphine. ಮತ್ತೆ detail study ಮಾಡ್ತೀರಲ್ಲ phosphine containing compounds, the best example is or one of the example is a phosphine. Okay, so it is also one of the method we have to use in the laboratory for the preparation of phosphine. So you know 2,4 ಇದೆ ಅಲ್ವಾ, ಅದಕ್ಕೆ usually making as a phosphine formation ಆಗಬೇಕು ಅಂದ್ರೆ 2 molecules of phosphine formation ಆಗುತ್ತೆ, again 3 molecules of sodium hypophosphite formation ಆಗುತ್ತೆ. So it is one of the chemical property of this phosphorus, the white phosphorus, when it is reacts with the concentrated NaOH. It is also one of the method for the preparation of phosphine when white phosphorus reacts with the concentrated NaOH. Okay, so come back to the red phosphorus. The red phosphorus is prepared by using a white phosphorus. We have to maintain certain condition here, the temperature, and we have to do the inert atmosphere. Same thing is happening in case of this phosphorus. The white phosphorus is when it is reacts with the sodium hydroxide. We have to like provide the inert atmosphere for this reaction. We have to maintain the certain conditions. ಯಾಕೆ ಈ ತರ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಈ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಏನಿರುತ್ತೆ ಅದರ್ ದ್ಯಾನ್ ಫಾಸ್ಫರಸ್ ಇಸ್ ವೆರಿ ರಿಯಾಕ್ಟಿವ್. ಈ ಫಾಸ್ಫರಸ್ ಏನಾಗುತ್ತೆ ತುಂಬಾನೇ ರಿಯಾಕ್ಟಿವ್ ಟುವರ್ಡ್ಸ್ ಆಕ್ಸಿಜನ್ ಆಗ್ಬೋದು, ನೈಟ್ರೋಜನ್ ಆಗ್ಬೋದು, ಡಿಫ್ರೆಂಟ್ ಗ್ಯಾಸಸ್ ಇರುತ್ತಲ್ವಾ ಏರಲ್ಲಿ, ಅವ್ರ ಜೊತೆ ಏನಾಗುತ್ತೆ ಬೇಗ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಅದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಈ ರಿಯಾಕ್ಷನ್ ನಡಿಬೇಕಾದ್ರೆ ಸುತ್ತ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಏನ್ ಮಾಡ್ಬೇಕು ನಾವು, ಇನರ್ಟ್ ಮಾಡ್ಬೇಕು. So especially in this case, ಈ carbon dioxide ಜೊತೆ ಏನಾಗುತ್ತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. Especially carbon dioxide because ಈ carbon dioxide ಏನಿದೆ ಆಕ್ಸಿಜನ್ ಇದೆ ಅಲ್ವಾ, is a very reactive towards oxygen. ಈ carbon dioxide ಏನಿದೆ ಆಕ್ಸಿಜನ್ ಇದೆ. So ಹಾಗಾಗಿ ಇದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಲಿಕ್ಕೆ we have to provide the inert atmosphere to the reaction. Okay, it is one of the chemical property. It is also one of the method. They will ask for competitive exam. It is very very important. Then come back to this red phosphorus. This is one of the method for the preparation of red phosphorus from white phosphorus. It is also exhibited the crystalline solid structure. Crystalline solids. At the crystalline solid structure, it is not poison compared to white phosphorus. Okay. Next, this red phosphorus is very very important. So usually it is also having some of the structure. So usually white phosphorus exists in a P4 molecule. It is also exists in the form of P4 molecule. But the difference is, in case of white phosphorus, it exists is a linear structure. Okay, only linear molecule. Only the molecular formula is a P4 formula exists. Okay, na? But in case of this red phosphorus, they exist in again a P4 molecule, but in a linear structure. What is mean by linear? If P4 molecules same agate, number of P4 molecules combined together to linear structure we call as a polymeric chain anta kariteve. See, it is exists in the form of a polymeric chain. Individual in case white phosphorus same agate, individual form exists agate only in the form of a P4. We call as a structure tetrahedral. But in case of red phosphorus, it is also exists in the form of a tetrahedral structure, but is each molecule we call as a P4 molecules combined to form a linear structure. The structure we call as a polymeric chain. Structure we call as polymeric chain. So only this red phosphorus exists in the form of polymeric chain. So ಯಾವ ತರ polymeric chain form exists ಆಗುತ್ತೆ? We see here. See, this is called as a phosphorus. It's a phosphorus. Phosphorus again, phosphorus. This is called as regular tetrahedral structure. In case of white phosphorus. Again, the next molecules is combined with another molecule of this sulfur. See. We have to see continuation. So, this chain continuation. It is not a branch, it is a linear structure. It is a linear structure. In linear fashion, molecules, one of the molecules the bond formation in between phosphorus atoms. Okay, na? So only we call it as it is a exhibit polymeric chain. Or polymeric form. What is the meaning of polymers? The number of monomeric units or number of single units combined with the linear chain of the branching chain. But in this case, they forms linear structure. Okay, it's a major difference between red phosphorus and white phosphorus. In case of white phosphorus, they exist in the free molecules in the molecular formula P4. Okay, they occupies the regular tetrahedral structure. But in case of this red phosphorus, it is also exhibit the P4 molecular state, but in a linear fashion. We call as a polymeric chain fashion. Okay, it's a major difference between this white phosphorus and red phosphorus. It's very very important. But in this case, the white phosphorus is insoluble in water, but soluble in carbon disulfide. We call as organic solvents and the organic solvents are soluble. But in case of this red phosphorus, they are not soluble in even water also and other solvents. This is one of the unique property of this red phosphorus compared to white phosphorus. Okay, the next form of the phosphorus we call as a black phosphorus. This black phosphorus usually it is also exists the next different forms. This black phosphorus matte different form exist usually we call as like alpha form matte beta form anta karite. Okay, so based on temperature we have to heat the white phosphorus or the red phosphorus. This white phosphorus or the red phosphorus na heat madidre we have to do some modify madbeku. We have to like modify some conditions, reaction conditions, especially the temperature. The temperature tumma important. Okay na, same substance at the same phosphorus na different temperature alla navenara heat madidre different form of compounds formation agutte, either white, red or black. Okay, so based on temperature. The next allotropic form is phosphorus. This dark phosphorus forms two different forms. One is alpha black phosphorus anta kariteve. Alpha black phosphorus and beta black phosphorus. See, this alpha black phosphorus is as one of the form we have to see in black phosphorus. So in this case we have to modify the temperature range. Same thing, ಈ white phosphorus ಮತ್ತೆ red phosphorus ನ prepare ಮಾಡಿದೀವಲ್ವಾ ನಾವೀಗ ಸೇಮ್ ಅದೇ phosphorus ನ ತಗೊಳ್ತಾ ಇದೀನಿ ಅಷ್ಟೇ. Beginning as a red phosphorus, the red phosphorus heated in presence of higher temperature. ಈ red phosphorus ನ ತಗೊಂಡು ಏನು ಮಾಡ್ತೀನಿ, higher temperature ಅಲ್ಲಿ heat ಮಾಡ್ತೀನಿ. Which is the temperature range here? Taken as red phosphorus, it is by heating ಅಥವಾ it is heated in presence of temperature range is 803 degree Kelvin. So usually we take as 803 Kelvin ಅಂತ ಕರೀತೀವಿ. ಈ 803 Kelvin ಅಲ್ಲಿ ಏನಾದರೂ ನಾವು ಹೀಟ್ ಮಾಡಿದ್ರೆ ಈ ರೆಡ್ ಫಾಸ್ಫರಸ್ ನ ನಮಗೆ ಏನಾಗುತ್ತೆ, ಆಲ್ಫಾ ಬ್ಲಾಕ್ ಫಾಸ್ಫರಸ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಆಲ್ಫಾ ಬ್ಲಾಕ್ ಫಾಸ್ಫರಸ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. So this alpha black phosphorus is formed when taken as a red phosphorus heated presence of higher temperature. The range is 803. Okay. Again taken as white phosphorus. White phosphorus heated in presence of 473 Kelvin. Heated in presence of 473 Kelvin. It gives rise to beta black phosphorus. See, only the reaction condition here temperature, different temperature aste. Different temperature alli different forms na whenever heat madre we get alpha and beta forms. We call it as alpha black phosphorus and beta black phosphorus anta karate. Okay na, formation agute. Usually in this case the red phosphorus produce alpha black phosphorus. It is does not oxidizes in presence of air. It's a very important. Okay. In this case, this alpha black phosphorus does not oxidize air. Nothing but oxygen jothe react agade usually. Okay, it's highly inert. But in case of this beta black phosphorus, it is reacts with oxygen but increase the temperature up to 673 degree Kelvin ವರೆಗೂ ಯಾವುದೇ ರೀತಿ ರಿಯಾಕ್ಷನ್ ಆಗೋದಿಲ್ಲ with the oxygen atoms. But more than 673 Kelvin, it reacts with oxygen. But in case of alpha black phosphorus, does not react with oxygen. We call it as a does not oxidize air anta karite. Air nothing but oxygen jothe react agade illa because of the condition. It's very important for our competitive exam. The white phosphorus is readily reacts with oxygen anta. But in this case, both alpha and beta form of black phosphorus does not oxidizes air. In case of alpha phosphorus, does not oxidizes air, but beta phosphorus it reacts with oxygen more than 673 Kelvin. Okay, the temperature increase matra enagutte oxygen jothe enagutte react agutte up to 673 Kelvin does not react with oxygen. So based on this, we have to see the different forms. ಈ rhombic sulfur and study ಮಾಡಿರ್ತೀವಿ. Rhombic sulfur, monoclinical sulfur and the same forms is also seen in case of phosphorus also. So based on this black phosphorus alpha and beta forms, we also see the rhombic form of a phosphorus and the monoclinical form of a phosphorus based on this different form of a phosphorus. Okay, you could end marketing a different structures na study marketing. So alpha matte beta. So this is regarding the some of the physical properties and features of this allotropes of phosphorus. Black phosphorus, red phosphorus, again white phosphorus. So two more question is very important for theory. Two more question. What is the difference between white phosphorus and red phosphorus? Okay, the white phosphorus usually the presence yav tara irutte. The white phosphorus yav formation agutte. We have to see it's a soft. It is a soft white color waxy solids anta helbodu in case of white phosphorus. Red phosphorus na tagondre it is a crystalline solids anta helbodu. Red phosphorus is our crystalline solids. In case of white phosphorus, it is exists in the molecular form P4, only P4. But in case of red phosphorus, it is also exists in the form of a molecular form P4 in a polymeric chain fashion. Polymeric chain fashion. This white phosphorus does not dissolve in water, nothing but does not soluble in water, but it is soluble in CH2, nothing but carbon bisulfates. But in case of red phosphorus, does not soluble in even water and carbon bisulfates. Okay, na adunu kuda enagutte soluble aguthe. Is a very important. But in case of white phosphorus, it is a poison in nature. Poison adu. But in case of red phosphorus, it not a poison in nature. So it the differences get. It's a 2 mark. Minimum we have to write 4 differences. So occurrence ಯಾವ ತರ formation ಆಗುತ್ತೆ ಹೌದಲ್ವಾ. So called as a crystalline solids ಎಲ್ಲೂ ಕೂಡ solid form ಅಲ್ಲಿ exist ಆಗುತ್ತೆ in different forms. Again, it's one of the poison in nature. Which one? The white phosphorus. And red phosphorus is a non-poison. ಅಥವಾ non-poisoning nature. So again, occurrence molecular form ಅಲ್ಲಿ ಯಾವ ತರ occurrence ಇದೆ ಬರಿಬೇಕು. P4 molecular formula ಒಂದು ಏನಾಗುತ್ತೆ complete molecular form ಅಲ್ಲಿ exist ಆಗುತ್ತೆ, ಇನ್ನೊಂದು polymeric chain form ಅಲ್ಲಿ exist ಆಗುತ್ತೆ. Okay na, again solubility na ಬರಿಬೇಕು. So this is we call as a differences between red phosphorus and white phosphorus. ತುಂಬಾನೇ easy. Okay na. So this is regarding the physical properties of both white phosphorus, red phosphorus and black phosphorus and differences. The next, the phosphorus containing compounds. The best example is a phosphate. ಹೌದಲ್ವಾ. Last section ನೋಡಿ ಇಲ್ಲೇ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. So one of the chemical property of the phosphorus, the white phosphorus actually reacts with the constantly in UOH. It gives us one of the compound we call as a phosphate. It's very important for your competitive exams, even theory also. So confuse ಮಾಡ್ಕೊಡಿ. Phosphogene ಅಂತಾನೂ ಬರುತ್ತೆ, phosphine ಅಂತ ಬರುತ್ತೆ. Phosphogene is a different, ಅಲ್ಲಿ ಬರುತ್ತೆ halogens ಅಂತ ಬರುತ್ತೆ actually. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ. So actually it is a phosphine. Phosphine formation ಆಗುತ್ತೆ. ಈ phosphorus PH3 is a formula for phosphine. So in this case, phosphate, obviously the preparation of phosphate in different methods, usually we call as a laboratory method ಅಂತ ಕರೀತೀವಿ, ಮತ್ತೆ industrial method ಅಂತ ಕರೀತೀವಿ. ಕೆಲವೊಂದು ಕಾಂಪೌಂಡ್ಸ್ ನ ಯೂಸ್ ಮಾಡಿ ಕೂಡ ಏನು ಮಾಡ್ತೀವಿ, ಫಾಸ್ಫೇಟ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ. ಓಕೆನಾ. ಇಟ್ಸ್ very important for your daily preparation of phosphate. The next compound is the sulfur containing compounds. The first example is a phosphate. The first method for the preparation of phosphate we call as a laboratory method. So say one of the chemical property of white phosphorus. Have you studied ಮಾಡಿದ್ವಲ್ಲ, same method. So usually we take as a white phosphorus P4. It is reacts with concentrated NaOH, concentrated NaOH in an inert atmosphere carbon dioxide. Nothing but reaction ಆಗಬೇಕು ಅಂದ್ರೆ ಆ ಸುತ್ತ atmosphere ಏನಿರುತ್ತೆ, we have to do inert, especially the carbon dioxide complete ಏನು ಮಾಡಬೇಕು, inert ಮಾಡಿ. Okay na. So it produced, we called as one of the important component phosphine. This is we called as a phosphine. 2 molecules of phosphine formation ಆಗುತ್ತೆ, phosphine with elimination of NaH2PO2. This is we called as a sodium hypophosphite. Sodium hypophosphite. How many molecules? 3 molecules of sodium hypophosphate in our formation. It is one of the method for the preparation of this phosphate. Okay, generally we call as a laboratory method. Laboratory method. So the next method for the preparation of phosphate, from using some of the metal phosphide. See, we have to use the word phosphide. From phosphide, IDE. So what is the meaning of phosphide? Usually ನಾವು nitrate ಕೇಳಿರ್ತೀರಲ್ವಾ, nitrogen ನಲ್ಲಿ nitrate ಯಾವ formation ಆಗುತ್ತೆ, so nitrate. So ಅದೇ ತರ phosphate, different oxidation state. In this case, the phosphorus present in the form of P3 minus ಅಥವಾ minus the form ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, exist ಆಗುತ್ತೆ. This is charged. The phosphorus in the form of phosphide. In the form of phosphide. This is we called as phosphide. Phosphide. IDE. They carries the charge minus. Okay. So by using some of the metal phosphides, here example is the calcium and sodium. ಈ ಕ್ಯಾಲ್ಸಿಯಂ ಅಂಡ್ ಸೋಡಿಯಂ ಈ ಮೆಟಲ್ ಫಾಸ್ಫೈಡ್ಸ್ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ವಾಟರ್ ಜೊತೆ ಆಡ್ ಮಾಡೋಣ ಅಥವಾ ದಿಸ್ ಮೆಟಲ್ ಕಾಲ್ಡ್ ಆಸ್ ಎ ಕ್ಯಾಲ್ಸಿಯಂ ಆರ್ ಸೋಡಿಯಂ phosphides reacts with water or these are reacts with water or dilute HCl hydrochloric acid either react with water or dilute hydrochloric acid to give rise to corresponding compound we call as a phosphate. Okay, see you have to see the chemical reaction. Usually one of the example for a metal phosphide is Ca3P2. This is we call as a calcium phosphide. Calcium phosphide. It is reacts with water. Reacts with water. Taking as a 6 molecule of water here, it gives rise to the compound we call as a phosphate. The compound we call as a phosphate. This molecule of phosphate formation ಆಗುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ 6 ಇದರವರೆಗೆ 2 molecules of phosphate ಏನಾಗುತ್ತೆ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ಪ್ಲಸ್ elimination of some of the byproduct here. In remain game ಉಳ್ಕೊಳ್ಳುತ್ತೆ ಕ್ಯಾಲ್ಸಿಯಂ ಇದೆ again water ಅಲ್ವಾ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಸಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ 3 molecules of calcium hydroxide. Same thing in case of hydrochloric acid. Instead of water additiveness the diluted acid. Acid ಯಾವ್ದಿದೆ hydrochloric acid. ತಗೋಬೋದಾ ಸೇಮ್ ಅದೇ ಮೆಟಲ್ ತಗೊಳ್ತಾರೆ sodium phosphide it is reacts with hydrochloric acid it gives rise to same phosphine 2 molecules of phosphine with the elimination of 3 molecules of the salt we call as the calcium chloride salt ಏನಾಗುತ್ತೆ eliminate ಆಗುತ್ತೆ ನಮಗೆ ಬೇಕಾಗಿರೋದು ಏನಿಲ್ಲಿ phosphine. It's one of the method for the preparation of phosphine from phosphides. It's very important. Okay. So they will ask you competitive exams like CET, NEET ಎಲ್ಲ ಕೇಳ್ತಾರೆ. ಇಲ್ಲಿ ನೋಡಿ different same gas formation ಆಗಿದೆ in different condition. So in this case we can't use the concentrated acid. Concentrated acid use ಮಾಡಂಗಿಲ್ಲ because ನಮಗೆ ಬೇಕಾಗಿರುವಂತ ಪ್ರಾಡಕ್ಟ್ ಇಲ್ಲಿ ಫಾಸ್ಫೈನ್ ಏನಿದೆ ಅದು ಫಾರ್ಮೇಷನ್ ಆಗೋದೇ ಇಲ್ಲ. It's highly reactive. ಹಾಗಾಗಿ different compound ಏನಾಗುತ್ತೆ ಫಾರ್ಮೇಷನ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. So only we have to use the condition here water or dilute hydrochloric acid. Dilute hydrochloric acid or additiveness of water molecule. Okay na? In hydrochloric acid use ಮಾಡಬೇಕಂತ ಏನಿಲ್ಲ. Diluted with sulfuric acid use ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ different compounds formation ಆಗೋ chances ಇರುತ್ತೆ. For example sulfates because very reactive. Okay, so ಹಾಗಾಗಿ instead of use water we have to use diluted hydrochloric acid. Okay, it is one of the method for the preparation of phosphate. The next method for the preparation of phosphate and the last method, so we take as a phosphonium iodide. Phosphonium iodide is one of the compound. It is reacts with KOH, potassium hydroxide. By heating up potassium hydroxide with phosphonium iodide. Phosphonium iodide. The formula for phosphonium iodide, usually ammonium chloride ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, so what is the formula ammonium chloride? NH4Cl. Same. Instead of taking as ammonium ಏನಿದೆ phosphonium iodide. The formula is PH4I. Phosphonium iodide heated with KOH, potassium hydroxide. Heated with potassium hydroxide, it gives rise to potassium hydroxide reacts with phosphonium iodide to give rise to phosphine with the elimination of the remaining byproduct is potassium iodide and water molecule. ನಮಗೆ ಬೇಕಾಗಿರುವ ಕಾಂಪೌಂಡ್ ಯಾವುದು phosphine. ಅಲ್ಲಿಗೆ ನೋಡಿ different methods either using by heating of KOH with phosphonium iodide. This is we call as phosphonium iodide. Heated with the potassium hydroxide gives us to phosphine with elimination of the byproduct we call as a potassium iodide and water molecule. So these three methods are very important for the formation of phosphine. These are the gas. Okay. So in the next classes we have to study what is the properties of this phosphine gas, what is the physical nature, again the chemical properties. We have to study in details in next class. Okay.